So let's solve another partial derivatives with constrained variables example. Here we have w is equal to 2x squared plus y minus 4z plus cosine t, and x minus y is equal to t. We want to find the partial derivative of w with respect to t, and we're going to keep x and z as constants. So we're going to fix the values of x and z. So first let's draw the chart. W is a function of x, y, z, and t. And from this equation over here, we see that the value of x depends on the value of y and t, same as the value of y depends on x and t, and the value of t depends on x and y. So if we change the value of y and t, the value of x changes. Y is also dependent on x and t. T is dependent on x and y. And we want to find dw dt. This is equivalent to saying it's dw dx times dx dt plus dw dy times dy dt plus dw dz times dz dt plus dw dt. And we're told that x and z are constants. Therefore, the rate of change of z with respect to t is 0. The rate of change of w with respect to z is 0, because z is not going to change. So the rate of change with respect to z is always going to be 0. We also know that the rate of change of x is going to be 0. So x is not going to change, therefore this goes to 0, this goes to 0. So this whole thing goes to 0. And we need to compute this and this. Okay, so dw by t dt is equal to, we take a look at this equation, this is going to be negative sine t. Dw by dy, we take a look at this equation, and this is going to be 1. Finally, we need to find dy by dt, so we need to compute this. In order to compute this, we're going to use this equation over here. So we know that x minus y is equal to t, so let's differentiate the whole thing with respect to t. So dx dt minus dy dt is equal to 1. And we know that x is fixed, so the value of x doesn't change. Therefore, even if we change the value of t, x is going to be the same. So this thing goes to 0. And we end up with dy dt is equal to negative 1. So now we know this is equal to negative 1. So if we want to find dw by dt, by keeping x and z as constants, here by fixing x and z, we get dw by dy, which is 1, times dy by dt, which is negative 1, plus dw by dt, which is negative sine t. So we get negative 1 minus sine t. And this is the final answer.